Hey guys, today we're gonna be doing a deep dive into the candidates test for calculus. Now, I did go over a little bit of it in my EVT and IVT video, but this time we're gonna work through every detail of an example. So let's say we have a function f of x equals x cubed minus 9x squared plus 24x minus 20. And we define it on the interval, closed interval from 1 to 5. And let's see, and we're going to graph it and then see where the relative extrema are and where the relative extrema are also. So first step, we're going to look at the interval from 1 to 5. And let's take so first we need to figure out what points are considered critical points. So the very first type of critical point is where the derivative of f equals 0. The second type is where the derivative of x is undefined. And third, you really want to check with your teacher if this is called a critical point or not, but nevertheless you must check this during a candidate's test. These are the endpoints. So depending on the textbook or the curriculum, these endpoints might not be considered critical points, so don't mislabel them or misdefine them on a test, but what you have to know about endpoints is that you still have to check them no matter what they're called. Anyways, let me quickly explain why each of these are considered critical points. So if we have a function where like the derivative is 0 at like this point right here, it means the function is going from increasing to decreasing, that's the maximum, or it's going from decreasing to increasing. That's a minimum. Now there are cases where a derivative of 0 does not mean a minimum or a maximum, but we still have to check them because we don't know until we look at the function. So, and derivative is undefined, weird things can happen at that point, so you also have to check for minimum, mins, and maxes there. And finally, endpoints, technically the derivative doesn't exist at the endpoints if we restrict the domain like this, but just remember endpoints you have to check. So let's take a look at this. So let's actually find the derivative here. F prime of x equals, come on, this is power rule with me, get some practice, 3x squared minus 18x plus 24. And of course the derivative of a constant doesn't matter. So now we need to find where that equals 0. So I think we can all agree there's no spot where this derivative is undefined, so let's skip this for now. And let's look at where f derivative equals 0. So let's factor this out. You can get a 3 and then everything, you have x squared minus 6x plus 8. And that actually factors nicely to x minus 2, x minus 4. So our critical points can only occur at x equals 2 or x equals 4 in this case. Now we don't have any for the second case where f is undefined. Now we also have to look at the endpoints. So at x equals 1 and x equals 5. So these are our so-called candidates for the extrema of the function. So let's look at f of 1 first. So if I do this in my head, I believe f of 1 is -4. And f of 2 is, hang on, 8, -36 plus 48. F of 2 is okay, 8 minus 36, -28 plus 48 minus 20, f of 2 equals 0. And f of 4, 64 minus 144 plus 96. F of 4 equals -4. And f of 5 equals 125 minus 225 minus -100. So f of 5 equals 0. So, alright, now remember, let's go back to x equals 2 and x equals 4 now. Now we can see that now we need to figure out whether these are relative mins, relative maxes. The absolute minimum and maximum is pretty easy to find. You look at the biggest value, which happens to be there are two shared values this time. So 0 will be the absolute maximum on this interval because these are the only places where it could possibly occur. And the -4 will be the absolute minimum on this interval. And it turns out two values share it, but it doesn't matter. The -4 is still the absolute minimum. Now, for the relative mins and maxes, these occur in the first two categories where the derivative is 0 or undefined. Now, to figure out whether x equals 2 or x equals 4, there's a relative min or max there, we use the first derivative test. So we can do this by, let's look at x equals 2 first. So we look at whether the derivative is positive or negative on the left or right of x equals 2. So let's plug in a nearby value. Let's say x equals 1. We find that the derivative is 9 at x equals 1. So it's positive on the left side of x equals 2. And if we plug in a value, let's say x equals 3, we find that the derivative of f is -3 there. So the derivative on the right of 2 is negative. Now, in this case, when the derivative is positive on the left and negative on the right, or when the function is increasing on the left and decreasing on the right, we know that x equals 2 has to be a relative maximum. So let's plot that here. And why don't we actually plot all the points that we have on our graph here. So I'm going to scale it a little weirdly. 1, 2, 3, 4, 5. Okay, so here are 4 points, and let's do the same first derivative test for x equals 4. So x equals 4. We already know what happens at x equals 3. The derivative is negative there. And let's look at the derivative at x equals 5, or to the right of 4. And we find that the derivative there is positive 9, the derivative is positive, and we can see that since the derivative is negative on the left of x equals 4 and positive on the right, x equals 4 is a relative minimum. And even though it also is an absolute minimum also, the absolute and relative you find separately. They can share the same answer or they don't have to. And now we can graph the rest of it. Now we can see x equals 2 is a relative maximum like that, x equals 4 is a relative minimum like that, and there is our function. So in summary, these are the 3 points, these are the 3 types of points that can possibly be extrema of the function, and our job is only to test all of them and see where and find the extrema and looking at every single possible value. To find the absolute extrema, you only look at which of the following outputs is the largest y value and the smallest y value. And for relative extrema, you look at the first 2 cases where the derivative is 0 or undefined and look at the sign of the derivative on each side. So if the derivative is positive on the left, negative on the right, an absolute maximum, negative on the left, positive on the right, that is an absolute relative minimum. And if the derivative is the same sign on both sides, which I didn't get to this in this problem, then there is no relative minimum or maximum for now. So I hope you got a little bit of practice on how to find critical points and how to do the candidates test. Remember, check all 3 conditions, plug in every single candidate, and then go from there. Hope this explained it a bit better, and see you next time. Please request more topics. And sorry for not getting to this before the quiz. Bye.